Welcome to tonight's Math Homeschool Connection Night. Tonight is going to cover geometry. We're going to cover everything that we're going to be doing with geometry. Geometry is one of our shorter units. So last couple of Homeschool Connection Nights, which have been about fractions and long division and all that stuff, where that requires a lot of computation, and we've had to kind of break them into a couple nights. Geometry is basically a lot about how much the student can recognize different things with geometry. It's one of our shorter units. We can pretty much fit the entire geometry unit into 2 weeks. We can fit the geometry unit into 2 weeks. It doesn't take a great deal of time, but there are some things just to go over to make sure that the students know what is best. So for those of you who have been here before, this screen you have seen multiple times now. The workshop is just to guide your students in helping to review their math tests that they get back. Or the really nice thing is, because this is happening before we get to the geometry unit, you can help them with their homework, anything they're struggling with on Excel or whatever else they're coming home. So it's going to prepare them for future tests and the eventual goal, the SOL, and hopefully it will help them to recognize mistakes before they even happen. Feel free to take notes. I have provided a paper copy too. This presentation is available on my website. I recently updated my website over the weekend because I was toying around with it, and this presentation is actually available on the home page now rather than having to go click through a bunch of different screens. So it made it a little bit easier to access this website or this presentation. And we will be going over concepts and test questions in general. If you have a specific question about your student, feel free to see me afterwards or shoot me an email. So the first thing we're going to get going on is points, lines, line segments, rays, angles, endpoints, vertices. Oh my, there are all of those things they need to know. That is SOL 4.10a. The whole geometry strand is the 4.10. Basically, they just need to be able to recognize that a point is a location in space and it has no length or width. The way that's going to be actually represented for them is it's going to say point A. It's going to be the way it's represented in words. The way it's going to be represented as symbol is a dot with the letter A with it. Pretty straightforward. Points, they don't generally have huge time with because it's the most basic one. A line is a collection of points. It goes on forever in two directions when they are representing it. The symbol is a straight line with 2 points on it and arrows on either side. The arrows represent that it goes on forever and ever because you feasibly can't draw it going on forever and ever. You run out of paper. Something to make sure that the students remember is that it's to represent it, you name just 2 points on the line. So you can do it in either order because it goes in direction in either order. So it's either line AB or line BA. Doesn't matter because it's infinite in both directions. And it's represented with a small line, so a line with 2 arrows on either side. Line segment is just part of a line, which means that one does not go on forever and ever. It's just one specific section. So that looks like a straight line with 2 points on either side, A and B. That also can be named however it wants because it doesn't matter A to B or B to A, it's still the same distance. So it can be either line AB or line BA. That's simply represented just by a straight line over with no arrows. So an endpoint can be 2 things. It can, one, be where line segments stop. So endpoints here for line AB is right there and right there. Or an endpoint can actually be almost, you might want to think of it as a start point because that's where the ray begins. So when we jump down to the ray here, that point A would be the actual endpoint, but it's really a start point at that point. Said point like 3 times in that sentence. The next thing that we're going to cover is array. Array is, the way I have the students think of array is like it's a ray from a flashlight because it originates from one point and in theory the flashlight goes on forever and ever and ever. So I like to think of the A as the light bulb and then the B as the light going out. That can only be named in one way because it only goes in one way versus lines and line segments go in either way. It doesn't really matter. Rays only go in one direction forever and ever and ever and ever. So that is always named with the endpoint first, or start point, if you will, and then any point on the line. So it always has to be AB with the line over it. It could not be named BA because it doesn't go in that direction. An angle is, the official SOL definition is that it is two rays that share the same endpoint. You probably know an angle as something that looks like this. So it's made of two rays. In this point, or in this example, it means that they both share point B as their endpoint and go out, forever and ever in any direction. It can be named in two different ways. It can be named A, B, C, or it could also be C, B, A, as long as the vertex, which is the point where they share, is in the middle, it doesn't matter. Or they can simply just call that angle B because that is the vertex, which brings us to the next thing, where it is the endpoint. The vertex is just when two endpoints meet and form an angle. That's pretty much overview. Truth be told, when I was looking through the released SOL items and the practice items and all the different resources from the Department of Education, this was the single only one question that I could find that related to that last slide, which tells me that the last slide there's not going to be a great deal of information on the SOL about. Doesn't mean they don't need to know it. It is important, especially as they get to the upper grades, but it just asks them to represent which is KL. And this question is pretty easy because there's actually only one ray on there. I mean, those are just 3 points on a plane. That's a collection of line segments. That's a line segment. That's the only ray. So if this is from a couple of years ago. I had to go back about 2 years before I could actually find something about that last slide. If they had something like this on the SOL now, I would be inclined to say that it would have this ray, and then it would also have a ray, but it would have the points switched. So that would try to trip the students up. But really, it's not going to, just identifying those things isn't really the large point. That is kind of introduced in 3rd grade. So that's more of a review standard. Actually, when I was looking for some of this to give you ways to practice on IXL, I actually had to drop down to 3rd grade to get one of those things. So it's more of a review standard. They don't even need to know obtuse or acute or right angles. That's covered in 5th grade, so it's not going to hurt them to know that now. We won't really get into that in class, but on some of the IXL things that I'll provide, it does get into that. It's going to prepare them for 5th grade, and I know 5th grade teachers will be very happy about that. But it's very basic, just show this particular standard training. They do occasionally make a couple of mistakes. Don't often see a mistake on this. The 3 common mistakes that I identified was simply confusing line and line segment, and that really comes back to semantics of talking about lines, because when you tell a student to draw a straight line, any from K all the way up to 4th grade, they get a ruler out and they draw a line, which is, they're technically speaking drawing a line segment. They just need to remember that a line in geometry goes on forever and ever, and a line segment in geometry stops. Generally speaking, I would say that would probably be the biggest mistake, just making sure that they understand that drawing a line for art is different than drawing a line in math. Confusing an angle and array, just because those are not quite as used in the lower grades, and plus because those are things that have one point and then arrows rather than a line segment, or excuse me, I'm screwing these up at this point. That the line has 2 arrows, the ray and the angle both have a point and 1 arrow. So, and then finally, going back to the identifying thing, that really would be impacted on the angle or the ray. It just means not identifying that. So like if it is, if it's a ray like this, and it was J, B, they are supposed to identify it as like that, but occasionally they will put it like that and it's going in the opposite direction, and that doesn't really work. So that they don't do that often because a lot of times they're not going to be asked to represent it or identify it. It's going to give them the notation, and then they're going to have to pick out which one it is representing. So we're going to move on to the ways to practice all these different things. IXL P29 will cover some of the stuff. You would have to drop down to kind of search through the IXL website a little bit, because some of this stuff is covered in 3rd grade, and I didn't realize that dropping down to 3rd grade was something I talked about later on in the presentation. But IXL P29 is going to cover the most basic of this stuff. Another fun way that we will do in class is using their bodies to model it. They would have their fist would represent an endpoint, and an open hand would represent an arrow. So I'd be representing an array right now, be representing a line right now. If I could close my hand the whole way, I would be representing a line segment. And then if you want to represent angle, you would have like their chest be the end, the vertex, and then those two would be the angle. So that's a quick way if you just want to do a quick check. If you know you're walking into a restaurant or something, you just say, obviously you'd have to prepare them for this, but you would just say, show me a line segment, and they'd go like this. They wouldn't be pointing. I just can't bend my finger right now. So really quick and easy way that Mrs. Burke had come up with was using marshmallows and toothpicks. Same basic concept, but you're just representing it in a different way. You get a marshmallow and toothpick. The marshmallows represent either an endpoint or a vertex or just a point. And then the toothpicks, the pointy parts, represent the arrow. So you would have to just kind of put that together. The other way that this is going to be, if you remember from the last homeschool connection nights about fractions, I was really harping on the power towers with the Pringle cans and the Dixie cups. The thing I'm going to really harp on now is going to be a math center called Polygon Pizza. I'm going to explain it to you. My set is not fully complete because our laminator has been broken for a month now. So I want to get mine laminated. But what I did to make this is I just got a pizza box. Pizza came with it. I ate that part. And then I've just got 2 pieces of paper. And on this one, I drew a bunch of lines intersecting. That's going to come into play later. And on this one, I put everything with geometry that they're going to need. It has all the polygons. You see here's array, point, line segment, or that's actually representing the endpoints. That's representing the vertex. That's a line segment. There's a line. So then the goal, what I'm doing with this is I will laminate it and put it in this pizza box. I actually had already put it in the pizza box before I realized that I wanted to laminate it, so I had to pull it out really quickly. And then what you do is this link down here that I provided, don't click on that quite yet because it's not fully made yet, but after you do make the polygon pizzas and after we do start, you click on this. I'll click on it to show you what it looks like, and it's going to ask me to authenticate. And it's going to give them flashcards. So for instance, it's not fully made and it might not be fully correct right now, but if you click on that link, it'll say which box shows point A. So for instance, point A on this is box 8. So they would put whatever marker you're using, just like a coin or something, down on that, and it actually self-corrects it. This is not correct because I didn't have this at home when I was making it, but when they click on it, it shows them what box it actually is. That should really say box 8. I can take a picture of this so you can have this specifically, and all you would need to do is print it out and cut it into a box, and then I'll make sure that this eventually does match this. But they're going to have this math center, and I have a feeling that they're going to enjoy it. And it's really nice because it is completely self-correcting with the flashcard things, and so there'll be a total of 25 flashcards for this, and then the additional flashcards there'll be additional flashcards for that. But we're just going to keep coming back to the Polygon Pizza as we go on through the presentation. So the next part is going to be what I like to call the interacting lines. There are 3 things, and this was introduced in younger grades. Might not have used the exact words, but they've seen this before. First way is intersecting lines. The official description is that they are crossing each other and they only have one point in common. So for these are intersecting lines that cross each other. They only have one point in common. The perpendicular lines are also intersecting lines, but they're a very special kind of intersecting lines. They form a right angle. It will be, most of the time, it will be represented with a little box there. That's the only reason with lines that they would need to know what a right angle is. They will need that when they get to the polygon, but that's the only kind of angle they will need. Sometimes it won't get that box, but they should be able to recognize that one straight across and one straight up and down will make a 90-degree angle. And set of parallel lines will never cross. They're always going to go, always be the same distance apart. They'll go next to each other, but will never touch each other. And it doesn't have to be like this. It doesn't have to necessarily be like this. The parallel lines can be like this, can be like this, as long as they're never going to touch each other if you would have set up the line. The way that they're going to see this are going to be in 2 different ways. One, it's going to give them the mess of this line, and in this one, it asks them to identify the 2 lines in the figure that appear to be parallel. This gets a little confusing because you see that technically speaking, other than these two that cut across, none of them are touching right now. But the students would have to realize that because there's arrows, it's going to extend. So J and K, while they're not touching right now, if you were to extend them, they would eventually touch. P and R, while they're not touching right now, if you extend them, they would eventually touch. Same with K and M, which only pretty much leaves you with J and M. So one thing when you're reviewing lines with them, make sure you always just kind of have them take a dotted line and just extend it out a couple more inches just to kind of verify that it's doing right. It might also be a street map, and rather than having letters for lines, it might say like Elm Street and Apple Street, and it would say which two streets are intersecting, which one are parallel. But it's basically, rather than getting down just like two lines and say, what is this? It's going to give them a map to look at. It's going to ask them which two streets are blah, blah, blah. Or it will say, if you looked at street or Apple Street and Oak Street, how could you describe them? They have to choose either intersecting, perpendicular, or parallel. Common mistakes, like I just said, is not extending those imaginary lines on this last one, not extending the arrows out with dotted lines. That's the biggest common mistake they're going to make here, because if you look at that without extending, it kind of looks like there are a bunch of parallel lines there because they're only P and R are crossing anything. But in reality, a lot of things are crossing each other. Mixing up what intersecting and perpendicular are, while all perpendicular lines are intersecting, not all intersecting lines are perpendicular. So they know that those two lines mean that they cross each other. Sometimes they just mix up that perpendicular is like the special version of a intersecting line. Ways to practice this is on IXL. P30 is going to cover perpendicular, intersecting, and parallel. I only did a couple of them, but that's not going to really give them that street map type thing or the mess of lines type thing. It's just going to give them like, here's two lines, what are they? Here are two lines, what are they? But I do know the really great thing about IXL, as they progress and get different medals, it does raise the difficulty level of the questions. I just didn't have time to sit there and play IXL for a couple hours until it gave me like a harder problem. Another really quick and easy way to do this, kind of going back to the using the arms, you just use arms model. So obviously this would be parallel, this would be intersecting, and then that one would be perpendicular. Really quick and easy way just to check their understanding. When you pull to an intersection, which has the word in it, intersecting, intersection, most of the time a lot of intersections are actually perpendicular sections, but that just doesn't roll off the tongue as well. You just ask them, look at the road, is it intersecting perpendicular, or if you're on a highway, most highways are going to be parallel to each other. You can just point those out. You can even just get to pens or pencils or straws, and you can just kind of put them down like this and be like, what are they? Right now they're perpendicular, or you guys can't quite see that, but right now they're parallel. And then you can, without even actually crossing them, you can do them like that and just be like, pretend they're lines. Eventually they're going to intersect. So that would be that. Coming back to my Polygon pizza, if I have, this is my version of the line drawing that I made. So on the Quizlet, the flashcard website, it would say which two lines are parallel, and they would have to choose line AB and CD, or I would say, well, how would you describe lines EF and J or GH? That would be intersecting. So again, that Polygon pizza, you make it once, it's pretty much going to cover everything that they're going to need to know for the geometry unit. I will make sure I take a picture and send that out sometime the next day or two. So the next part of the SOL is transformations and congruence. 4 words that they need to know here. One of them is reflection, rotation, translation. Those all go along with the transformations, basically the way that the shapes are manipulated. And congruence is just a fancy word that means same side for same. So let's go through them one by one. I'll just show you different ways that I help the students to remember. So reflection is that the figure is flipped over a line, and that line is called the line of reflection. So on each of these, the left is like the original shape, and then the right is it's been transformed in that way. So here's the dotted line here would be the line of reflection. They might have called this a line of symmetry in younger grades. At this point, we do call it a line of reflection because we're not representing symmetry here, we're representing transformations. So they basically take this and flip it right over. So you like I like to say that reflection has an FL in it, flip has an FL. That's a good way to remember reflection and flip. Basically, they have to think of that they're looking in a mirror and it's flipping it over them, just like their reflection in a mirror. Rotation, generally speaking, they don't mix up rotation because they've heard the word rotation. We did it in science with the Earth, and they've probably heard rotation just like they hear Mr. B saying, rotate your body so you're sitting like a normal human being. And so they hear that frequently, and they know they need to turn their body so they're sitting facing me rather than looking out the window at the snow. So that just means that it was started here, and it was rotated 90 degrees or 180 degrees or 270, or the whole rotation would be 360. Doesn't necessarily need to be exact 90 degrees. As long as it's turned, that means it's a rotation. Translation is, it's a really long definition, but basically what it boils down to is that it is slid. What the SOL says is that every point on the figure is slid in the same direction and the same distance, can be moved in any direction. I just tell them, if I say translation, that means just slide it. So all they did was they took this shape and just slid it over here. It can be moved in any direction. Doesn't flip over anything, doesn't spin. All it is if like you took something and you just moved it around. Way I tell them to remember that, translation has an SL, slide starts with SL. Really quick and easy way to remember that. Final thing, that final vocabulary word from this part of the SOL is congruence. It means that there are two shapes that have exactly the same size and exactly the same shape. Can be moved, can be rotated, can be reflected, can be moved however it wants, but it's going to be the same size and it's going to be the same shape. So this pentagon right here, it was like that. All I did was I rotated it, didn't change the size at all. So it's congruent to that one. This one, while I didn't change the shape or the orientation of it, I did make it smaller so it's not congruent. Another word, one second. One word that they won't need to know, but I needed another space on Polygon Pizza, so I got to teach them this too. It's called similar, which means that it is the same shape but not the same size. So they don't necessarily need to know it for the SOL, but they will eventually need to know it. I taught it last year and it didn't confuse the kids or anything, so I always like to throw in extra stuff when possible. So this pentagon and that pentagon would be similar because they are the same size, but they're not the same shape. So they wouldn't be congruent, but they would be similar. You got a question?
So virtually, except for the one with the X in it, all those shapes are congruent.
Yes. Yeah. Okay. Because all I did was I just moved them around. So yeah, they're all congruent. It's just the X one is not. Good question. So a couple of different ways to, that they're going to see this. One way it's going to say which pair of figures appear to be congruent, and you can see that all of them are basically the same shape. This one's the only one congruent because it's been rotated, but it's the same size and same shape. These ones are similar because it is the same shape. They've just been rotated, but that one's significantly smaller. Those ones aren't even the same size or the same shape, so there's no official math word for that. Same thing down. Well, actually, those ones are similar because they're just rotated and they're smaller. So that's one way they're going to see it. Another way that they might see it is they'll give them one shape and it'll say, of the following, which ones are congruent? And it's going to have a bunch of rotations or translations or what have you. And I'll have some that are smaller, so they have to choose. Like if you get a triangle, they'd have to pick all the triangles that are exactly the same size, exactly the same shape. They wouldn't want any ones that are smaller or bigger. It doesn't matter if they're rotated or what, but they just need to pick that. The other way, and this is going to be the one that's going to confuse them and trick them the most, is it's asking which one is showing a single reflection over line R. Now, if they just look at just the shape here, they could say that this one's a reflection. The reason this one is not a reflection is because the design within the shape hasn't been properly reflected. This one is a reflection because the design in the shape has been properly reflected. That's one been rotated and reflected. That one's just been translated. So they're going to do things like that, purposely try to trick them with the design, so they always need to make sure that they're looking at the design. Because I mean, if they're just looking at the shape itself, that clearly looks like it's been reflected, but you can see that it hasn't actually been reflected. That's actually, they rotated that. Actually, they didn't do anything to it. They just moved the shapes with it. So common mistakes is going to be forgetting what the words mean. the 4 words we just reviewed, the reflection, the rotation, the translation, or the congruence, just simply forgetting what those words mean, which is why I try to get them those little clues. FL for reflection, for flip, rotation, rotate your body, translation, the SL for slide, and congruent, just that it means the same size. So I try to relate equivalence or congruence to equivalence because we're working on equivalence with fractions right now. So they know that that basically means has something to do with being the same as ints. And also, like what I had just said, not looking at the symbols within the shape. That's going to, I would be very surprised if they didn't have a question like this. And it will try to trick them like that. So they just need to make sure. That kind of comes back to the whole slowing down, making sure they're reading for details. At this point, they're really looking for details in picture, but just make sure that they're looking for that because those two, I mean, if I gave this as an assessment and if they didn't get that one right, I would pretty much bet my bottom dollar that they would pick that one because that's the only one that's been reflected. So this is what I said I had to jump down to 3rd grade for this to look at transformations, which is the translation, rotation, and reflection. They're actually going to have to go into the 3rd grade standards on IXL because IXL is aligned to Common Core, but then they did go back and they realigned it to Virginia Standards of Learning. So in all of the rest of the United States that use Common Core, the transformations is a 3rd grade standard. Simply, the only way that you access 3rd grade standard rather than 4th grade standard is when you go on IXL, rather than clicking on math and then 4th grade, you just click math and then 3rd grade. And then it's R7. Congruence is going to be IXL. That's going to be back in 4th grade. P11, that will also cover the concept of similar versus congruence. That's why, especially if they're using IXL at home, that's why I'll kind of reinforce that class. You can always tell them that. You can use toys and cutouts to show this. So what you would do is if you had, probably should have some sort of shape to use. If you had just a little shape here, like I have a little square here, and I would put designs on it just so you can really show a reflection. If I would take this and then I spun it, that would be a rotation. And then you can slide it around or you can, flip it. That'd be a really good way. Cut out whatever shape you want. Square's not going to work as well because square pretty much looks the same no matter how you spin it. But putting a design on that is going to be what they're going to have to look for. So actually, yeah, use a square because then that's going to force them to look at the design. And again, going back to the Polygon pizza, I have a couple things that actually happen to end up being in a row. So that one would show a reflection. That one would show a rotation. That one would show a translation. Right here, these would be congruent, and these ones would be similar. So Polygon pizza, by the end of the night, you would see me saying Polygon pizza because it's good, but it's going to be a really good way to review, and it doesn't take up a whole ton of space. It takes up about the size of the pizza. Just don't try to eat it after you put it inside. So the last thing, and this is the thing that is going to probably trip them up most out of all the geometry thing, is all the different shapes. And I need to kind of digress a little bit here. This is the part of the standard that I have the biggest problem with because at no point in the 23 years I've been alive have I ever needed to know what a nonagon is or a decagon. I can't really think of a situation where it would actually be applicable to life unless I was taken hostage by like a terrorist who really liked geometry. But I mean, this part of I can see why the other parts of geometry are important, but at no point, I understand like knowing triangle, pentagon, the more common ones, but I don't really see a point in knowing some of those, but they screw them up. And when I was student teaching in 3rd grade in Pennsylvania, they also needed to know what a 12-sided figure was, which is called a dodecagon. I have never encountered a dodecagon in the wild, so I don't know why they would possibly need that, but they still need to learn it. I just think that this is one of the part of the standards that I don't quite agree with this. I don't see the practical application for this. So the first vocabulary word they're going to encounter is a polygon, and the official definition of a polygon is that it is a closed geometric figure with at least 3 line segments and no curves. So basically all that means is that it's a shape that is not a circle, or it's completely closed. So a circle or like a semicircle would not be a polygon because it has a curve in it. A triangle that looks like that is not a polygon because it's not fully closed. Something completely different that we're not going to get into. So that is basically, polygon is just a fancy word for shape, is what I have them realize. They just need to know that while they're thinking shape, they can't think circle because the circle is not a polygon. We actually don't cover circles in fourth grade or three-dimensional shapes. We just stick to the second dimension. So the first one obviously is a triangle that has 3 sides, 3 angles. Easy way to remember that is a tricycle, or an even easier way to remember that, they are in fourth grade. At this point, they should know what a triangle is. Triangle is probably one of the very first things they learn as we're growing up. So triangle, they don't even need to get into like obtuse, scalene, isosceles, acute. They don't even need to get into that. They just need to see 3 sides and 3 angles and know it's a triangle. They will, again, get into isosceles, scalene, obtuse, all that goodness next year, but that's not something that we worry about in fourth grade. I did skip quadrilaterals because quadrilaterals was going to be the second slide, because there are, under quadrilaterals, which are 4-sided figures, there are like 5 of them that they need to know. And again, going back to that, I've never had someone come up to me and be like, I need to know what a parallelogram is right now. So one day, maybe, and then I'll send out something on class mentor and say it finally happened. But so we're gonna skip ahead to the 5-sided figure, which is a pentagon. The easy way I have them remember that is the Pentagon in Washington, D.C. Most of them have seen pictures of the building. We even talk about it in social studies because the proximity to Virginia. So they pretty much know Pentagon. So pretty much triangle and pentagon are the ones that they remember the most, and square and rectangle, obviously. It's the ones from hexagon down that kind of trip them up. So I've come up with different ways to try to help them remember that. So hexagon is 6-sided. And the hexagon has the letter X like 6 does, and has 3 letters just like 6 does. So that's how I have them remember that. Heptagon has 7 sides. Hepta has 7 letters. Hepta has 5 letters. Can't even read what I've written. Okay. Hepta has 5 letters. 7 has 5 letters. That's just how, because they a lot of the times will remember that hexa and hepta are the 6 and the 7. They just can't remember which one goes with which, because they kind of use process of elimination to realize which one's which. Octagon is 8 sides. I tell them to think of an octopus. I hesitate to tell them to think of a stop sign, even though a stop sign is a octagon. But they're not gonna. We'll see some examples where they're not going to represent these sides in what you would, or these polygons in the traditional way you would see them. Like a hexagon sign can be the pretty thing that looks like an octagon sign. If it's just going to be like a crazy design, they have to actually count the sides. Nonagon is 9 sides. Never seen a nonagon, or need to identify it, but nonagon kind of sounds like 9. That's how I have them remember that. And a decagon is 10 sides, and a decade is 10 years. A lot of them actually do that last year without me having to say. I was trying to get, like, tie in some time stuff, and I was like, now what's a really good way to remember decagon? Does anyone know, like, 20 hand shot? They're like, yeah, decade's 10 years. And I was like, okay, I'm just gonna go home. So those are all the polygons aside from quadrilaterals, and we'll get into how they're going to actually have to recognize those. So the quadrilaterals are a separate beast of themselves because there are 5 things that are under a quadrilateral. So quadrilateral simply by itself means that it has 4 sides. And then underneath those you have the 5 specific kinds of quadrilaterals. So there are all of these 5 have 4 sides, they just have different things that make them a quadrilateral. So these descriptors were taken right off the Department of Education's website. A rectangle has 4 right angles. I would include, but the Department of Education did include, that it is 2 sets of parallel sides and 2 sets of congruent sides. That's just how I always remember what's a rectangle. So then they define a square as a rectangle with 4 congruent sides. So this is where they start getting a little mixed up, because a square is a rectangle, but a rectangle is not a square all the time. So basically, it means a rectangle or a square means that they have 4 sides that are exactly the same size. Generally speaking, they're not going to screw up the difference between a rectangle and a square, because again, going back to triangle, they've been working with rectangles, they've been working with squares. It's these bottom 3 that are going to mix them up most. So trapezoid means it has exactly one pair of parallel sides. trapezoid is going to look like this. It's going to kind of look like a triangle with the top chopped off, or it's going to look the other way that I couldn't get to actually show up on here. It's going to look like that. That's not really parallel, but let's pretend it is. So it's going to look kind of like a right triangle with the top chopped off. So as I'm actually saying this now, what I just kept saying is it looks like a triangle with the parts that are cut off. Triangle starts with TR, trapezoid starts with TR, so they can kind of think of that. I'll have to remember that when I'm teaching this in a couple weeks. Parallelogram is that both pairs of opposite sides are parallel, so these two are parallel, and those two are parallel. The thing that then gets tricky is a rectangle is also a parallelogram. A square is also a parallelogram. So technically speaking, if it gives them a bunch of shapes and it says identify all the parallelograms, not only would they have to represent that, they also have to choose that and that. And that kind of thing will happen. And then finally, a rhombus just means it has 4 congruent sides, so all sides are exactly the same size. So a square is also a rhombus. So you almost need like a giant Venn diagram to figure out this is what, it's kind of like a big family tree. But they just need to be able to recognize the descriptors, and there's they might not need to represent them as or identify them from a picture, but I will show you some of the questions. It'll give them statements about different quadrilaterals, and they have to choose which ones are true, which is probably the next slide. So we'll start with this one, and we'll go to the little box there. The very important thing to point out about this is that it's not going to be they're not going to ask them for like what you would consider to be the traditional representation of the polygon. When you think octagon, the first thing I think of is stop sign, because that's what when I think hexagon, I think the thing that's like that. When it's going to show that, it's going to have a bunch of designs, and it's going to say which one of these are showing, well, for this question specifically. So which set of figure is showing only octagons. So what they would have to do is they would have to count all of the different sides on each of them. So like for this one, it has 1, 2, 3, 4, 5, 6, 7, 8. So that one's an octagon, but they also have to count this one to make sure that's an octagon. 1, 2, 3, 4, 5, 6, 7, 8. So those two, as long as I count it correctly, those do both happen to be octagons. But using test-taking strategy, you can't just choose that one. They do have to check the rest of them. So that has 6 sides, and that has, well, so that would eliminate that one right off the bat, because that one only has 6 sides. Questions asking for both of them to show octagons. So this one would be 1, 2, 3, 4, 5, 6, 7, 8. So that one is an octagon. Then you have to check this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that one is an octagon, but that one is not. So that's why that answer would not be valid. And then I think error or 1, 2, 3, 4, 5, 6, 7. So that one is heptagon, and that one is also a heptagon. So you see that it doesn't show you a stop sign shape. They actually have to go ahead and count the signs. So they can't rely on just knowing, oh, octagon is a stop sign. They can't rely on knowing what the things traditionally look like. They have to actually realize using like the prefix what each shape goes with. The other way that they're going to see it is, I apologize that it's a little small in there, but you do have it on your screen. It's going to have, those are going to be one of those technology enhanced items where they're going to be allowed to pick more than one answer. So it says, which of these descriptors are true for a rhombus? So they could pick 6 answers. They could pick 1 answer, 2, 3, 4, 5, 6, or they could pick none. Pretty much I'm going to tell them don't ever not pick an answer, because I don't think they're going to put a question on there that has no answer. So they have to go through, are there exactly 4 sides in a rhombus? Yes, that's true, because it's quadratic, so they click on that one. All angles must be congruent. That is not true. The angles are not all going to be 90-degree angles. A square and a rectangle all are congruent angles, but not in a rhombus, even though a rhombus or square can be a rhombus, but not all rhombuses are squares. All sides must be congruent. That is true. That's in the definition. There must be at least 1 right angle. That's not true, especially for quadrilateral. If you have 1 right angle, you're going to have at least 2, not all 4. So that's not correct. There are exactly 3 vertices that would describe a triangle. Pretty much any time they see 3 on anything related to polygon, they immediately need to go ahead and realize that that is a triangle. And both pairs of opposite sides must be parallel, and just with it having to be congruent, that is true. So they would have to choose those 3 answers. It's not going to tell them on this, well, how many questions they're going to have to, or how many choices they're going to need to select. we have been working with this kind of thing in class with every Friday when they're taking their reading quiz. They do see these kind of things where they can pick more than one answer. They do that on the Chromebooks that you guys are working on now. So they are getting familiar with this. That was one of the big things from last year. We didn't really practice with the technology enhanced items. So, they get through school and they realize, like, you come to a multiple choice test, you can pick one answer, and that's it. When they get to those, they can pick multiple answers. So it's just really getting those on. So I've just been playing around with the templates for those. I do have those templates for, like, the reading quizzes that have come home. If you want me to send you, like, the templates, just give me an email on whatever your Google Drive stuff is, and I'll send it to you, and then they can work on that at home too. But big takeaways here, especially for the quadrilateral, they need to know, like, the definition versus necessarily the picture, and that's not going to be the traditional representation of anything. So a common mistake is going to be not counting the sides correctly. What I mean by that is when they're counting the sides here, not counting them correctly. I mean, you saw I was even having a little bit of struggle trying to figure out which sides I had counted already. So what I tell them to do is actually go ahead and as soon as they count that side, I've never seen if this works, but it didn't work. But actually just go ahead and cross that side off so you know that you've already crossed that off. And once you cross off all sides, you know that you're done. So that's what I said there. Just cross off all the sides, and that's a way to ensure that you have counted all the different sides. Confusing hexa and hepta is going to screw them up because, again, they can remember non, nine, octa, octopus, decagon, decade, pentagon. So hexa and hepta is going to screw them up the most. Really remembering that the hex has the extra, just like the 6 does. It's going to help them, all that. Confusing all the different definitions for the quadrilaterals is going to be huge because, especially with them all relating to one another, now I will not tell the students that unless they kind of realize I don't know, because I don't want to cause more confusion for them. Quadrilaterals, I would say, out of everything in geometry is going to be what's going to trip them up, especially because you don't see them that often. Or you might see them, but you might not be like, oh, that's trapezoid, that's a parallelogram. Every year when I teach geometry, I have to refresh my memory which one's which. So that's just not something that I work with on a daily basis. And not verifying all shapes or information. That's what I mean for this one. Maybe they counted, which I think it was this one was 8 sides, and so they might count one side and be like, or one of them and say, oh, there's 8 sides, I'm going to choose that one. They need to check both of them. What I mean by not verifying all information, it's going to be here. They say, like, oh, there's 4 sides in a rhombus, I'm good, I'm going to move on. Hopefully, working with the technology enhanced items for reading quizzes and pretty much leading up to it, will get them in the habit of realizing that, oh, when you see something that looks like that, most likely you're not going to pick just one answer. Make sure you're looking for all the different answers. So ways to practice this is going to be IXL P1, 6, and 9. P6 specifically is going to go a little bit above what they actually are going to need for 5th grade. It's going to give them, that's going to identify, I believe if I remember correctly, that one is identifying polygons. And that's going to throw in those words like scalene triangles, isosceles triangles, couple things like that. They're going to need to know next year, so that's a good way to get a head start on that. When they come up to that question and say, Mom, Dad, I don't know what this word means, or I don't know how to even pronounce this word, just have a quick discussion with them on what that means. There is also on IXL something about 3D shapes, so if your student could pretty much masters those ones and just looking for just a little bit more enrichment, go ahead and do the 3D shapes. Not going to need to know that, but I think 3D shapes are cooler than 2D shapes. So another way to practice this is to just get a whiteboard piece of paper and just draw a bunch of crazy shapes. Don't make them traditional. Don't do just a stop sign. Don't do a standard hexagon. Make them non-traditional. Make them go and cross off the sides as they're counting. Have them prove to you why it's a hexagon, why it's a decagon, all that kind of stuff. That's going to really prepare them for everything. And finally, one last time, I knew you were probably hoping that it was gone, was Polygon Pizza, which is how the game gets its name. So here I have, this one would be a trapezoid, that one would be a rectangle. For the quadrilaterals, I even did them a little bit of a favor, and I wrote little definitions underneath so they remember what it is. Triangle, I think I had represented everything. Now here I did put an octagon, like a normal octagon, like a stop sign. But then on the outside, like this one, I think that's a decagon. That looks like a kind of like a shape. I think that one ends up being a nonagon, I think. That's a star. So whenever you're making this yourself, feel free, just go on Google and you type in decagon or whatever you want, and it'll give you crazy shapes, and you can replace the octagon with something a little bit more crazy. Or you can even just draw them on yourself. That's another option. I just have really bad handwriting, so I just printed those off. And that does conclude our night for once. I'm actually done well ahead of time. Because this is a short part. But I am very thankful for you coming. I know coming to school at 7 o'clock might not be your thing that you want to do on a weekday night. But it's going to really benefit your child. Make sure you're going through this stuff with your child. It's like I say every night, you coming to this night is great, but it's not doing anything unless you work with your child, because while you know a lot about geometry right now, and they'll know a lot about geometry, and whenever we get into this, then it will kind of all mesh together. We are still working on fractions. I was hoping to have fractions finished by the end of this week, but with the rain of snow last week, it kind of has shifted everything. We'll most likely begin on geometry. I would say, what's today? Today is the 10th. I would say we'll probably get started on this sometime late next week or early the following week. And we'll pretty much go in the order I did tonight. So if you want to get started on it with your child, it's not going to hurt them because it's not too technical of stuff to teach them. But if you want to wait until I get started, just go ahead and ask me where we are in math, and I'll be more than happy to do that. Final thing I need you to do is the next slide is the feedback slip. You guys pretty much know what to do. You don't need to put it in the basket. I don't know why I still have that up there because it's all digital. And our next one is going to be a reading night. That is going to be March 19th, so next Thursday. I think that is inferences, predictions, drawing conclusions, and author's purpose. I think those are the 3 skills I picked out for that. And our final math night for March is going to be March 24th. There's a very high potential that March 24th might also turn into a review for benchmarks. Benchmark window has been shifted a couple times with all the snow. I don't know if I'm going to be able to squeeze another math night in before benchmarks. So I'll send out a class messenger thing as soon as I know when benchmarks are. So then, because if whichever one is a benchmark review, it's going to be a very, very important one to be here for, because that's going to pretty much review everything that we've done in the quarter, just a quick refresh. But as of now, I think the benchmark window is April 1st through 15th. So that there's potential I normally put the math benchmark last, so we have all the time to review. But I'll let you know if that March 24th one does turn into a benchmark review on top. We might just take out probability and put benchmark review in, just put probability to the next one. So before I stop the recording, do we have any questions? Good. All right, let me go ahead and stop the recording, and then you can speak freely.